Hi everyone. Those of you new to Idaho State University may not be aware that we have a tradition of doing Bengal Wednesday, and since I'm making this on a Wednesday, we are actively doing Bengal Wednesday, showing our pride in ISU. So today we're going to talk about basic functions. This is something that has not been emphasized enough in pre-calculus. A lot of people don't understand that Math 1170, which is the start of the engineering calculus sequence, is not the same thing as Math 1160. You're in Math 1160, and the focus on applications really changes what you do. So a lot of stuff that happens in Math 1170 does not apply to you. So I'm going to take a very different take on some of the things that you learned in the prerequisite pre-calculus course and make them so that you're well set up to be doing applications. And what we're going to do here are the basic functions, and this is in my book. The link to that is on Moodle, and so we're just going to jump right in. So, well, we'll just jump right in. So the first of the basic functions is y equals x. And that the graph of that is a line, slope 1 goes through the origin, and that's about what you need to know about lines, is that y equals x. We're going to modify that. That's something that was covered but not emphasized in pre-calculus, so we're going to emphasize that. The next basic function is something that you probably worked with a lot already. It's y equals x squared. The graph of that is a parabola, and that has a point that's the most important point, which is the vertex, and for that particular version, the vertex is at 0, 0. The next one that you didn't work with in this form, but probably should have, is a hyperbola, and here's the graph. The equation that you would have learned for this is y equals 1 over x, but that's not so useful. You know why? Because that involves dividing. That's how I got this scar in 8th grade, so I don't like to divide. So I'm going to use xy equals 1. The pre-calculus course focuses too much on functions, which is not necessarily what happens in applications. So this one also has what I might call an anchor point, the origin, 0, 0. And it has two asymptotes, the horizontal asymptote and the vertical asymptote, and the anchor point is where those two meet. Never the twain shall meet. No, wrong. The next one that did not get emphasized anywhere near enough in pre-calculus, or probably in anything else that you've done, is the circle. And the basic equation for a circle is x squared plus y squared equals 1. And so there's a circle. The interesting point about the circle is it has this origin, and then you've got the radius. You can't really make that into a function. It's not a function because it doesn't pass the vertical line test. It's not a function graph, excuse me. But it's so useful and so illustrative of how we deal with these kinds of things that we're going to do it anyway. And the final one, which is not covered in pre-calculus at all, which was a mistake, is the sine function, y equals sine x. And for the moment, we're just going to leave that as a function built into calculators that has a graph, and there it is. If this comes up in so many applications, we've got to talk about it. So that's it. That's all we have to do with graphing. Thanks very much. See you next. Oh wait, there is more. Each of these graphs has an anchor point. In each of these graphs, the anchor point is the origin. And so here it is for the line, and here it is for the parabola, the hyperbola, the circle, the sine function, and remember the sine function repeats and repeats and repeats. And so the next thing that happened in pre-calculus that was not emphasized enough is the following. If you change x to x minus 4, you move 4 units in the positive direction. If you change y to y minus 4, you move 4 units in the positive direction. And so one of the advantages of the way I've written the circle and the hyperbola is that you can see that you're going to be subtracting from y when you do these kinds of things. These things move the anchor point. So for example, if I do y minus 4 equals x plus 1, so that's something that you, oh wait a second, that's all wrong. You got to do it with the minus sign. You got to subtract it off. So we have to rewrite this as x minus minus 1. Y minus 4 is x minus minus 1. You can't have minus minus, you have to have parentheses. So here we have something. This is in point slope form, by the way, which is the best form for doing calculus, so you're going to be seeing a lot of that as well. Anyway, what we have here is a line, slope is 1, and these transformations have moved the anchor to minus 1 comma 4. That's it. There's the line. You can put the axes in later if you need them. Many times you do not, so don't do it by habit. We can do the same transformation to a circle and say x minus minus 1 squared, this time I'm getting smart, plus y minus 4 squared equals 1. So I've moved minus 1 to the right and 4 to the up. Y minus 4 moves things in the positive y direction, that's up. And so that's just a circle, radius 1, but now the anchor point has been moved to minus 1, 4, and the radius is still 1. So there's what we do with the circle, and that's it. No, it isn't. That's not it. There's another thing that we do with these graphs is that we stretch or shrink them. And so let me write down the rules for that. 4x shrinks x by a factor of 4. 4y shrinks y by a factor of 4. And so let me just do what we just did here with the circle. Let me take that circle that we just did 4 times x plus 1 squared plus, so I'm doing a shrink. I'm doing a separate shrink in each axis. And then y minus 4 squared equals, I'm sorry, 36. I'm going to write down the wrong thing. So here's an equation for a circle. Something squared plus something squared is a number, that's a circle. And what we've done is we've shrunk it and moved the anchor point around. So the anchor point is just exactly what we did over here. But now we've applied separate shrinking on each axis. And at this point, you do have to do a little bit of algebra. Divide through by 36. So we're going to get a fraction. Top is x plus 1, quantity squared. Bottom is 9. Plus another fraction, y minus 4 squared on top, divided by 36 is equal to 1. And so I divided through by 36, and 4 over 36 is 1 over 9. 1 over 36 is 1 over 6. But what we've done here, if you look at the original form, is shrunk x by a factor of 4. Well, we haven't quite done that. So we need to divide through by 36. Anyway, so what you end up with is a graph like this. I don't have quite enough room. But the anchor point is still at minus 1, 4. Um, and but now we've been shrunk in the x direction by a factor of 4, and we didn't do anything in the y direction except the radius was 6, and so you get this elliptical thing like that. One final note: every now and then you'll run into someone who doesn't understand that you're doing applications, not just algebra, and they'll give you something like this. I am writing something ugly down, and you're going to look at this. This is like looking at a giant spider. So I'm writing down this ugly, ugly, ugly equation, and here you go. It's got 8x squared plus 6xy plus 7y squared plus 5x. This is an ellipse just like the one we last did, but you're going to have to do a lot of algebra to make any sense of this. If somebody gives you this, they're a bad person. Stay away. So practice with the basic functions. You won't have to do stuff like this, 8675309, but stuff like this, moving the anchor points, that's the big deal. The homework has some stuff to do with that. And then please use the forums and let me know if you have questions, or send me emails, or stay in touch. Thanks.